Mr. Lucy.
Hello,
How
Mr.
are you
Raleigh.
today?
Good to see you again.
Okay, today we're going to focus on the lab portion and laboratory in chemistry, which is essential to the course. We are going to do tons of labs this year because it's a hands-on course, and the way that you learn chemistry is through the laboratory. Well, I think that one of the best ways to learn chemistry is through the laboratory. Okay, so why is the laboratory so important, Mr. Lucy?
Well, in science, we like to collect data. And you've done that in your biology class. You've done that straight through physical science if you took that class, or straight kindergarten, straight through grade 8. So now we're in a chemistry class. And we're going to be a little bit more specific about how we collect data, how we record that data, then what we do with that data. So first thing, we have two types of data. We have qualitative data and quantitative data. You're going to hear those words throughout the course, throughout the year. So you should be able to know the difference between those two. So we've collected a whole bunch of data. Great. Well, you can't really see what that data looks like.
Yeah, so what do we do?
So I think what I can show you is there's a whole bunch of data that was collected from
our first lab. This is a lab, I don't know if you've done it yet or if you're going to do it. It's finding out which is the most efficient height for heating, because we're going to be doing a lot with the Bunsen burner this year. So let's look at this data, Mr. Lucy. What do you think is good about this data?
What good about the data is that we have a lot of it. So it looks like we have a number of groups who did multiple trials. So in chemistry, we like to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's nice. So we get a lot of information on what's happening heating that water on the Bunsen burner.
Okay,
what do you like about that?
I like that they have units here, but I'm a little bit uncertain about, were they really able to get a height of 15.00 centimeters? I mean, can we do that in the laboratory so that the height of that beaker above the Bunsen burner is exactly 15.00? I think that maybe the estimation should be in the tens place rather than in the hundreds place. So you should know that. What tool, what measuring device are you using to collect the data, and where is that estimated digit? So significant figures should come into play here.
Absolutely.
So I'm not sure if all of this, I'd question this data, okay? Also here, what's missing? I see numbers. This is not a math class.
I am assuming we're in Celsius?
Yeah, I'm sure.
I'm
the
sure.
Thermometers that we have are
We're
Celsius.
probably Celsius.
But they should have that.
That needs to be listed.
Yeah.
And as well as we go over here with the scale reading, right? Because that's what reading a ruler is, reading a scale. This is,
all over the place.
Seems to be a thermometer reading issue. So once again, there's limitations on that ruler we're using. There's limitations on that thermometer we're using.
Is it the same scale? Well, look at that. Maybe this only goes out to the 10, so maybe it goes to the ones place. So there's some questions here, and you should be thinking about the answers to these, and you should be thinking about what instruments you're using to collect the data. Okay.
Right, and what I find most troublesome is right here. So this is at 0 minutes. This is taking that thermometer from where it's stored in your chem lab, and before you even put it into the water, or maybe putting it into the water, determining that. So maybe they started with all different temperatures of water from the tap. Notice these questions we have. So we shouldn't have these questions by looking at a data table.
Okay.
So now that we have data, great, Mr. Rinaldi, we see all that data on the chart, but I still can't really see any sort of relationships with what's going on.
Yeah,
so
we want to be able to predict behavior. That's why we're going to graph it. So let's look at a graph. Yeah, there we go. So this is a student that lab group generated the graph. Okay, what do you notice that's really important?
Labels on axes. So I know this is time. If I lower this a little bit, you'll probably see the word time there, and it'll say time in minutes.
Okay, I like that. I like the y-axis is labeled. We're going to be looking for that. Temperature. They've got a title.
Yep.
Okay, and most times I really don't like the idea of connecting the points, but maybe for this lab, I'd rather see a line.
Right, best fit line.
Best fit line really shows the difference in slope, which will show us which is the most efficient line, most efficient distance for heating. So But overall, pretty good. I like that you could see this is a much better representation of that data than the columns of numbers.
So we come back, we have a whole page full of data. You can't really make heads or tails out of it. Then we graph the data. It's coming into picture as to what's happening because we're very pictorial. Then from there, we tend to turn those relationships, into formulas. And if you'll remember, some of the formulas we used in some of the earlier videos were the density formula, we use a volume formula, and there's a couple of formulas that we'll be using in the next unit with our pressure, volume, moles, temperature formulas here. So this is really where we go. This is based on a graph, which was based on data collecting in a lab. So you need to always think of where we're going with this. In our class, we tend to do all three when we do gas laws. We really do.
Right.
And in some labs, we'll stop here.
Right. But notice how this is a progression, a process. This is how you do science. This is how you do science. You get the data, make a graph, there's your evidence, and from that evidence, you create either a theory or a law. These are mathematical laws right here. Okay, so that's the importance of laboratory in science. Add any more?
Yeah, there's one more. We have.
The keeping a lab notebook. So we're gonna keep a lab notebook, and this lab notebook, you're going to have to follow the protocols to make sure that you have it every time we do a lab, and we will check this lab notebook. Okay, so once again, the format of the lab notebook. If you make mistakes. Okay, just cross them out. We want to see your thinking process. First 2 pages have to be for the table of contents. What are you doing in the laboratory this year? So make sure you leave some empty pages there. All the other pages, you have to number. You have to put the number on the upper right-hand corner. You got to follow this exactly, guys. In college, when you have a lab notebook, the prof signs off on that lab notebook. We're going to try to do that too, but we're basically preparing you for the college experience. Contents, you could just read through this. You could read the pre-lab. All of this is self-explanatory. What we want to get to here is the real difference between data, observations, calculations, and results, okay? So procedure, you could copy the lab sheet or just put the lab sheet in there, make note of any changes. Data and observations, this is very, very important. You want to just write down your data. In the lab, many students. What's the problem here, Mr. Lucy?
Well, you leave the lab and a day or two goes by and then you want to go put information into that lab notebook and it's not of the same quality. So it's really is key. It's not to be copied into your notebook at a later time.
And everyone
right.
takes data. Do not leave it up to one person, because if that person is absent, then you don't have it. So please take the data.
And we've said over the years, if you're working in a group of 4, one person has the data and they've been out, the other 3 people, you don't get a good
You're
grade.
lost.
You're lost. You can't do
And
it.
many labs happen a couple of days, so you need the data from the day before.
That's right.
Okay? And then, all right, back up 1 minute. Data is anything you collect with an instrument. So in the first lab, we collected the data using a ruler and a thermometer. Anything you collect with an instrument, okay? On the other hand, calculation and results are
Any mathematical operation done on the data, averages, percent errors, lines from a graph.
okay? And all of these should be labeled once again, show the calculation with units, show the formula you're plugging into. You just only have to show, if you're finding the density, okay, show one sample, right?
Right.
Okay, results. Now, this is where kids get confused. Results is, you're gonna have a results table. Your results table includes the information from your calculations. So after you've calculated everything, all your final answers, you've only shown one calculation, but all the other calculations go into the results table, okay?
So in essence, very quickly, because the data, numbers collected in the lab, done, chart.
Good.
Any sort of math done on those numbers, averages, mean average, mode average, any sort of averages done on it, anything, calculations done on it, multiplication, subtraction, division, square root, that's shown in the calculation. One calculation per type you have. The answers to all of those calculations are on a results table, and that's where your graphs also go.
Okay, and then your final conclusions and discussions. You could do any or all of the following, what fits best with the data. A statement, what was learned, explanation, etc. Error analysis.
And if you want to not earn the maximum number of points, or let me say it again, do not use human error. We know you're human, and we know you're going to error. Don't write human error.
So if you made a mistake, all right, there could have been a mistake in a measurement. I could have read that incorrectly. Describe the error. Do not say human error.
And
Okay.
we know this video went on a little bit too long, but you're going to have a ton of questions on this lab notebook, and we're there to help you with this because you're using this all year.
All year.
And our plan is to have some sort of an assessment at the end of the year where you get to use your lab notebook. So the better record keeping you keep in September, the better off you're going to be in April.
Yes, this will be on the final exam. There will be a lab question on that
Yes.
final exam and in the midterm.
Yeah.
And so you can use your lab
You can use
notebook.
your
So
notebook.
do a good job. Okay?
Thank you.
you. How long is this? 20?
It's 11.
Oh.